Well, if you like mining and living, this is the panel for you, so you showed up to the right place. Again, my name is Michael Foster. I'm sales manager at Maddox Transformer. So what I'd like to do is have each gentleman introduce himself and tell us a little bit about your company. So we'll start over here.
Sure, thanks. So I'm Gerald, Wilkie, president and founder of HMTech. We're a mining and ASIC repair facility located outside Raleigh, North Carolina, founded in 2014, so we've been around for a little while and haven't died yet, so that's, I think, why we got the invite, de facto.
Yeah, that's great. Ken?
Ken Worton. I am the owner, founder, CEO of Quality Electrical Systems. We're a specialized electrical equipment manufacturer out of Salt Lake City, Utah. Been designing and manufacturing electrical equipment now for about 25 years. And just kind of primarily spent most of my life in the oil and gas and water, wastewater, and mining industries manufacturing electrical equipment. Bitcoin's new to me, but the amount of power that we're seeing involved in these Bitcoin operations is made it a really interesting market for us.
Yeah, so our industry is kind of the wild, wild west, or at least it has been. You've got people coming in from all sorts of industries with some pretty big knowledge gaps. So at Maddox, what we do, we build transformers, and we've seen some interesting problems. Probably the biggest one we've seen is people think 1 megawatt equals 1 MVA in a transformer in terms of the power you need. And theoretically, that's true. But when you run a transformer at 100% the whole time, you're going to get failures like you would with any electrical device, electrical components. So we've had to coach people not to do that so they're not blowing up transformers and having their whole operation go down and things catching fire. So that's probably the biggest thing we've seen. And when we deal with crypto clients, we've got another panel member. Eduardo, why don't you introduce them?
Yeah, sorry for crashing here. Yeah, my name is Eduardo Barbi. I'm a sales engineer at Maddox Transformer as well. We manufacture transformers. I think last year we sold just about 1 gigawatt worth of crypto transformers, so we're pretty experienced in the segment.
So as I was saying, basically what we've seen is people charge up their use transformers at 100% instead of 80% like you should. That's causing problems. I'm interested in knowing what you guys are seeing in your industry. What are some common mistakes or just risks that people are taking because they don't fully understand the components? I'll start with you, Gerald.
Yeah, thanks. So we have some of the same polite conversations with clients as well, where we do consulting across the U.S. for different crypto operations, and density is everybody's favorite word. Like, how many can we get in a rack? How high can we load this circuit or this branch? So 100%, and then you get the cowboys, because it is the Wild West, right? A lot of these guys are like, oh, it'll run 110%, it can take it. Sure, for a little while, and then it's going to catch on fire and you're going to be completely dark. So the overloading of gear is really, really common. The other thing that some folks miss, and this is really a municipality problem, is in an effort to attract crypto businesses, a lot of tech parks will waive inspections as long as you have a licensed contractor to do the work. Which, from a political standpoint is a gain, right? But from a safety factor, it's terrible. So some of the spaces that we've gone to, help people undo some of the mistakes they've made or to make them more efficient, we see wires not in conduit, we see poor grounding, we see just these huge gaps in safety that is potentially going to cost somebody their life. So that's a big red flag for our industry is safety, and having folks that are licensed, that are engineers. Having folks that know what they're doing draw up their plans, their schematics, and their prints before they get to work, because we'd like to get things done right now. That's the Bitcoin space. It has to happen today. If it's not online yesterday, we're late, and sometimes there's gaps that happen in safety, and it's a bad recipe.
Yeah, that makes sense. People are in such a race to get up; they're not thinking about staying up, right?
Yep. I think probably the craziest thing we've seen containers without earth ground, which. You've got electrocution box.
Yeah.
It's there's just take a few extra minutes. Spend a few extra grand, pay the engineer, get your work done, laid out correctly before you get going. Is the big rock, I think.
Yeah, Ken, how about in your side of the industry? What are some of the common dangers or risks that you see people taking just because they don't really understand those components?
Well, one of the things that I see most commonly is people are putting down a transformer, maybe it's a 2 meg transformer at 2500, and it's going to produce 3,000 amps of current that they can use to mine with. They're not thinking about how many amps of fault current that transformer can produce, and they're not using electrical equipment that has the appropriate fault current ratings. And so, a circuit breaker is designed to open a certain amount of fault current. So a circuit breaker has 2 ratings. It has its current rating, and it has its fault current rating. And a lot of people are just not familiar with the fault current rating concept. And so when you put down a transformer that big, there's a lot of fault current available. It's easy to have, in excess of 65K on some of these larger transformers, especially people that want to put down one transformer and feed more than one container from that transformer. Each container may only have 1,000 amps or 2,000 amps going to it, but if you put down a transformer big enough to feed multiple containers, your fault current is very high. So if you're using a circuit breaker that doesn't have an appropriate fault current rating for that size transformer, and you do have a short, the circuit breaker cannot safely open. It expels its guts in the form of an arc flash. So that's the thing. When I first was asked to build electrical equipment for mining, it was a container builder that came to me and said, hey, can you handle the power distribution within this container? And I looked at what they were doing, and I was like, not like that. And they were actually, there's 3 types of circuit breakers, right? You've got UL 489 branch circuit rated devices that are actually legal for taking a large source and branching it off to a smaller load. And then you've got UL 1077 breakers that are supplemental protectors. They're really only thermal protection. They have to be backed up by a branch circuit device. And then you've got, and this particular builder was using a breaker that was more like an automotive breaker. It was one of those little push-in breakers that was literally thermal only. It didn't even have an instantaneous feature on it. So in a long-term thermal overload, it would trip, but in a short circuit, it didn't have an instantaneous capability. And so just using the right protective device and having those devices set up in a way that you're not going to shut down your main because you have one miner over here fail. That's probably the primary thing that I've seen that doesn't look like anybody put any forethought into the engineering.
Mm-hmm. Eduardo, I already mentioned the undersizing of transformers. What are some other things that we're seeing that are kind of cutting corners, taking unnecessary risk? Is there anything else that you could think of?
Yeah, not a whole lot more to add. I think we have another transformer expert here on the panel. I think installation, installs, and not having the right contractors that have medium voltage experience has been something that we're seeing lately. And then if you skip that step, you likely pay the price.
Yeah. I need a 15 kV transformer. Right. What do you mean? You mean 12,470, 13.8, 13.2? Yeah.
Yeah, I think we've seen a maturing in the industry for sure this year, especially guys who are more electrically savvy and aren't just willing to cut all the corners they can to get it online as soon as possible. But that's still a major deal. Just lately I learned about a whole container that burned up for the same reason over there that we were just hearing about.
Usually when the electrician shows up and they're like, man, I ain't never seen nothing like this. Go a different direction, like stop immediately.
Well, let's talk about UL listed. The guys at UL Solutions are behind that. It just means that it's been tested according to whatever standard that was set. With that in mind, why should containers be UL listed? And is that the same thing as having the parts that make up the containers themselves UL listed?
It's a good question. So we are a UL listed manufacturer. I don't think that you can certainly build safe equipment without it being UL listed. What the UL primarily provides is some level of assurance that there was some testing and some forethought into it. Non-UL listed components scare me a lot because they're not tested. You don't, here's a circuit breaker, it's a 100 amp circuit breaker, and it's supposedly going to interrupt 65K. Does it really? If it hasn't been short circuit tested, if it hasn't been through UL's lab and proven that it will actually do what it says it does, that's a dangerous component. That's not something that I want to work with because you just don't know. As far as an overall system listing, now you've got something where all of the wire sizing, all of the conduit fill rates, all of that kind of stuff have been looked at. And it's another thing that is just, how much risk are you willing to take? Just because it's UL listed doesn't mean that somebody didn't make a mistake either. I'm a UL listed manufacturer. UL's not in my shop every day inspecting everything that I do. It's sort of an on your honor thing, but they do come in regularly, and if they find something that doesn't comply, you are at risk of losing your listing, and your listing is very valuable to you as a manufacturer, so we are very careful about making sure that we do everything according to the standard. The other thing that I worry about with a non-UL listed component is, as a mining company, you're going to carry liability insurance. And, my insurance carrier as a manufacturer walks through my facility, even your workers' comp insurance. Those guys will walk through your facility on a fairly regular basis. And if they're seeing non-UL listed stuff, that's a big red flag to them. So the cost of using UL listed equipment, you're going to make a chunk of that back just in insurance savings.
Yeah, that makes sense. How about you, Gerald?
Yeah, I was going to say, I'll tag on to that real quick from the implementation side of things. When you've got container manufacturers that are UL certified, that really helps local inspectors get you a CO and get your equipment ready to go and deploy at a faster rate. So what happens is when you go to these places and, like a Rockdale, Texas, a Dalton, Georgia, or any of the other hotspots, the local inspectors, prior to a few years ago, they didn't even know what Bitcoin was, right? So we're coming in with these containers and we're putting in, 5, 10, 20, 50 meg worth of gear, and they've never seen anything like this. So for them, a lot of times they're creating delays by calling state-level inspectors or people that have, experience talking about dealing with inspecting installations and projects of that scope. When there's a UL sticker on there and that's stamped, for them, that's kind of a green light. So they know that inside the container, there's no need for them to really have a second look. They know it's going to be safe, and there's not going to be a situation where somebody could get hurt or get killed. So they feel better about passing it. Because when the inspector signs off, the county or city, the locality is taking liability. They're saying, yes, it's safe to operate. So by putting the UL sticker on there, that's going to speed up your time to deployment because the inspector is going to feel better about it.
Yeah, it makes a lot of sense. Basically, it greases the wheels. Not only is it safer, but from getting just things up and going and making money, you're greasing it. You're going to make up the lost time, big time, at the back end.
For sure, because they've seen transformers get installed. They've seen services installed, no problem. But to get them inside a container and say, is this to code, yes or no, it's going to be a long process without that UL stamp.
Yeah, ultimately for us, I think all our new transformers are UL listed, but what matters most is that the equipment's been tested in some way. So even when we remanufacture something, we have to put everything through a test so we're not just setting something out there dangerous. Anything to add to that one?
I see some non-American manufacturers of transformers, so not on the container side, use non-UL listed components. So we've had some problems, well, not as Maddox, but just customers reaching out to us, sharing some problems they've had with bushings, especially coming from non-American manufacturers. So that's something to watch out for.
Yeah, for sure, because typically that's an auto fail. Because if like for transformers, for like state level inspectors, that's typically an auto fail if it's a non-US made. So that's gospel.
You kind of answered it. Oh, go ahead, please.
The other thing that I would add is 2 code updates ago, in terms of the NEC code, an NRTL certification became code. Now, not all municipalities, not all jurisdictions necessarily adopt the latest version of the NEC. Most of them are at least one version behind. But even, in our industry, it's like, is that a UL state? Is that not a UL state? If it's going to California in the last 25 years, if it doesn't have a UL sticker on it, it's not getting energized, period. Washington, New York, there's some states that the inspectors are really focused on those UL labels. There's some states where, they either just barely adopted the latest code and an NRTL sticker is required. And a lot of those inspectors aren't necessarily paying that much attention yet, but it's part of the NEC now. So it is code. Doesn't have to be a UL label. It can be an ETL Intertech label. It can be, any other legit NRTL label. One of the things people don't realize is NRTL is actually falls under the jurisdiction of OSHA. So the NRTL label is actually an OSHA thing.
Yeah. So you got UL, you got ETL. You kind of answered this already, Ken, but I don't know if you would comment further on or you would have something to add. But why is it being UL or ETL listed? Why does that not immediately equal safe?
Yeah, I guess that it should immediately equal safe. The only reason that a listed component would not immediately equal safe would be either a defective component or a manufacturer that is a listed manufacturer that's not necessarily following the standard. And there is a formal process. If you find something, and I've found many things in my career, you walk up to a piece of equipment and it's a labeled piece of equipment, but there's a clear problem with it. Those things need to be reported to UL. UL goes back to that manufacturer and says, hey, you're doing something wrong here. And usually it's a retraining issue. I don't think most UL, I think a manufacturer that gets a UL listing is pretty serious about building good equipment. So I think most of the time if that occurs, it's because they have, personnel that need additional training or something like that.
Anything you say, Chad?
No, I would totally agree. It's rare, right? So when you get one of those UL stamp pieces of equipment, you can feel pretty good about it. And statistically speaking, and this is obviously nothing to back this up, but 99% plus. I mean, it's very rare to find a UL piece of gear that doesn't meet spec.
Yeah, it's just you want to have multiple redundancies. That's one redundancy, and then people actually understand the equipment that's being installed. So if there was that rare mistake, they'd catch it. So what is ISO 9001? How would you guys explain that certification and its value in this industry?
ISO 9001, the current standard is the 2015 standard, and it's basically a quality process. So if you're an ISO manufacturer, you have to state exactly what your quality process is, and you have to follow your quality process, and you are actually audited once a year, and it's like a week-long audit, and they come in, and if they find one document on your shop floor that doesn't have the right revision on it, anything like that, it's a minor, what they call a minor infraction. And if you get a couple of minor infractions, that equals a major infraction. Majors sort of stop you, right? That's kind of where the audit stops. You have to correct it. If they find a couple major infractions, they'll pull your ISO certification. So, and then every 3 years, you go through what's called a recertification audit, and that is a very in-depth, I mean, they literally have access to everything in your facility. They can pull folders from previous jobs. They can, they literally can look at anything in your facility to make sure that you are following your quality process. And you can kind of make your own quality process, but they're obviously within their boundaries. And if they find a problem on the recertification audit, then you lose your ISO certification. So a company that has an ISO 9001 2015 standard certification is a company that is paying attention to their production processes, and they're dotting their I's, they're crossing their T's, they're doing their inspections. It just ensures quality of product.
Yeah, it's QA process more or less. Eduardo, could you explain what arc flash is? I think a lot of times in these conversations, we all say big words, and not all of us know what we're talking about. What is an arc flash?
Well, it's definitely not something you want to experience. We'll start there. Yeah, I'm not an electrical engineer myself, so I'm not sure if I'm going to give you a textbook definition. But definitely when you don't have the proper insulation and the proper installation of electrical components, you may experience these currents that are going to
Discharge somewhere.
discharge where they're not supposed to. It was funny the other day. There was a storm in Greenville, South Carolina, where I live, and all of a sudden I hear this great boom, and I see this arc flash in my fireplace, actually. So I just learned that if you're pulling up some metal piping, gas piping into your fireplace, you need to actually ground that, and they didn't do it when they built my house. So that was fun with my 1-year-old running around the house. That was quite dangerous and fun to see a little burn mark in in the fireplace. So it is very dangerous, and it is a matter of, I guess, grounding and insulating things properly.
You've already talked about this a little bit, Gerald, but how does arc flash, why does it matter when it comes to containers?
Well, let's back up just a little bit. So
Sure.
I've got a little story about this one, right?
Yep.
So I've been in the business a long time, and part of my background is engineering. And I think we get really comfortable with a lot of the numbers that we throw around. I've got a 50 meg site, 100 meg site, it's 2,500 MVA, just crazy numbers, right? This industry is full of them. And we don't stop to think about what we're actually saying a lot of times. And it came home to me a few months ago. I got to my facility, 6 a.m. like I normally do, rolling through. One of our power distribution cabinets was energized, but it was off. It's like, man, that's really weird, but we've got some clients down. Let me figure out what's going on. So I go to the switchgear. One of our main 350 amp branches was down, was tripped. So I was like, man, that's, still not thinking about it. Only 1 cup of coffee in, right? So I'm just like, oh, let me just reset it. The main branch should never trip, right? It's not something that should happen. Like, that should have been a warning sign in my head. But again, you just get so accustomed to it that you're dealing with megawatts every day. So I just reset it, re-energized it, but what I didn't realize is in the PDU cabinet, one of the mains had broken where the lugs go in and take the 480 in. So it had actually broken. The aluminum just, for whatever reason, I guess manufacturing defect, had worn out. So my A and B phases were welded together.
Oh, man.
Right. So when I re-energized that, there was an arc flash of epic proportions. Thankfully enough, it was properly grounded because, electricity is lazy, right? It wants to go to ground. So being that the switchgear was properly installed, grounded to the building water main and an earth ground outside, when I re-energized it, the insulation caught most of the arc flash. These 3 knuckles lost the skin, so it burned it off just because of the heat. Because you're talking about thousands of degrees instantly. If it would have been improperly grounded, I wouldn't be here. I'd be in a puddle, right? So in the container, it just exacerbates that same problem because the entire thing is metal. So you're literally in like an electric chair if it's not done right. So the grounding, the installation, all that is absolutely critical because, it was just stupid. A main lug in a power distribution cabinet should never break. Should have never happened, but it did. But because the grounding and the work was done correctly, I'm still here, which is awesome.
Mm-hmm. Yeah, we needed you for this panel.
Right.
How about we talk about grounding a little bit? Ken, could you explain grounding and how it relates to kind of arc flash and the safety of containers?
Well, I think I've not heard that one. Electricity is lazy. It wants to go to ground. That's a really good one. But basically, if you ground everything around it, so if the electricity decides to get out of its containment, then it is going to go to ground and not heat up everything else. There's in this industry, fortunately, we're primarily dealing with 415, 240, a Y-connected source, so we have a good ground reference. You get in the marine industry, some of these industries where you're dealing with, ungrounded deltas and stuff that gets really scary. This industry, we're primarily dealing with a Y-connected transformer, so the center tap on the transformer is your neutral, is grounded. And so long as all of your electrical containment is grounded correctly, then if an insulation failure occurs, it's going to go to ground, which will take your voltage to 0 and trip your breaker, so you don't have anything heated up for any period of time. Super important. You've also got a data component to this industry. So I've got a lot of Cat 5 going on. Having a lot of ungrounded or improperly grounded equipment is going to add electrical noise, and it's not just a safety issue, it's a communication issue. So you can end up having problems with communication. And it's because the power supply in a miner rectifies the AC power to DC, so it's a rectifying device. Any device that rectifies is going to not draw power in a linear fashion. It's going to, instead of drawing a power in a normal sine wave, it's going to draw power in gulps because it's rectifying. And that creates power quality problems or harmonic distortion. Harmonic distortion heats up transformers. All of your tripling harmonics, any multiple of 3, circulate in the delta winding, cause additional heating. But they also cause imbalances that lead to stray currents. So you now can couple current to ground even if you don't have a leak. So in a normal 3-phase system where you've got all 3 wires together, if you put a CT around all 3 wires, you measure 0, hopefully, right? But when you have power that has harmonic distortion present, you don't necessarily measure 0, because mathematically the waveforms don't cancel each other perfectly. You've got these pulses of power that are not necessarily perfectly offsetting. That allows you to couple energy. So there's inductive coupling and capacitive coupling that you deal with in the electrical world, and there's honestly the capability for both, because inductive coupling is an AC thing, capacitive coupling is a DC thing, and you've really got both present. So you can couple energy to ground, and if ground isn't grounded, you can couple enough energy to ground that it'll shock the crap out of you. I actually did a project up in Cache Valley, Utah, a dairy where the cows just refused to come into milk. They would not do it. Cows are much more sensitive to electricity than humans are. A cow can feel voltages that we can't feel. And so we took our engineers, we took some scopes, we took some stuff up there, and we found out that they had, in this case, variable frequency drives running on their equipment, and they didn't have appropriate grounding. And there was about 36 volts present, and the cows could feel it, and they wouldn't come in there. And once we got it grounded properly, got rid of the 36 volts, the cows were happy. So
That's great. So Bitcow would be a great company to launch for safety. I can see the marketing already. Anything you want to say on harmonics? We deal with that a little bit in transformers, quite a bit.
We do, yeah, for sure. It can definitely be a concern in data centers. No doubt we've seen more requests for higher K factors lately. So that's something that manufacturers can usually do, is just manufacture transformers that are able to withstand a higher harmonic rating. So that's definitely something to keep in mind. I don't see necessarily as much talk about it as I think there will be in the future.
Especially with these container-based solutions. You're about to say something?
I was just going to say, as a transformer manufacturer, I think it would be really helpful for a lot of people to explain exactly what K-factoring is, what you do internally in a transformer when you build a K-factor rated transformer, because I think that's something that a lot of people throw around and maybe don't understand exactly what you're doing inside the transformer.
Well, Gerald, you might be able to tackle that better than me. I just know they're beefier, tougher transformers in a nutshell, but...
Exactly, yeah. I'm not going to be able to give you a much more precise explanation of that right now, but definitely be happy to come back and do some research, talk to the electrical engineers, and give you a better explanation later.
That's what I got my tech guys for. How would you explain it?
The delta winding, the primary winding in the transformer, is oversized because the tripling harmonics are circulating. You can actually have 1.73 times the circulating current on the delta winding that you have passing through the transformer. So you've got a transformer that's got 1,000 amps, going in, and the ratioed version of 1,000 amps coming out, but you potentially have 1,700 amps circulating on the delta winding. And so K-factoring the transformer is just literally a matter of oversizing the delta winding. You don't have to oversize both windings because it's not affecting the output winding.
Yeah, that makes sense. Anything on harmonics you want to say?
I like the idea of a beefier transformer. Years ago when I first started and we did one of our first builds, we actually wound up using the Liebert cabinets that have got linear filtration just for that sole purpose. And it's expensive. Brand new, I think those cabinets run 50 or 60 grand. So if we could get transformers that have got that built in, I think that's a step ahead of the curve, especially for crypto miners, because we want to look at what our price per megawatt for build out is, and not having those cabinets and having transformers that can handle it is a huge win.
Yeah. Well, let's talk about safety equipment, personal protective equipment, PPE. What are some of the big ones that are needed for mining operations, and especially what are some of the things that you guys see overlooked when it comes to that sort of equipment?
So yeah, I'll jump right on that one. So we've had a bunny suit, right, full deal, because you've got these primaries on the switchgear. So if you have a blackout, you literally have to pump these breakers, right, and then energize them, right? So confession, I used to do it without any PPE until I got the arc flash kind of wake up, and just straight up that scared the shit out of me. So I was like, all right, never again. So I think it's critical: the gloves, the hat, the little baseball catcher jacket, the boots, like the whole 9 yards. Like what you wanted to get is the best rated gear that you can get, because it only takes one instance or one time when something shouldn't have happened, and it did. You lose an employee, right? A contractor, whatever. It's totally not worth it. The PPE gear is less than $1,000. You can get everything you need. Just do it. Like there's no argument. You talked about the ISO 9001. As far as production go, you've also got OSHA that comes to visit. There's all these different certifications and processes that we could follow, but we like to go fast.
Yeah.
And we take these shortcuts, and it costs people. It costs their lives. It costs injuries. You've got downtime. Workman's comp will cancel you. Your insurance leaves, and your mining operation is over because you didn't put on a glove. I mean, just do it.
Slow is smooth, smooth is fast. Eventually, right? Yeah. Right. What would you say, Ken?
Well, it's interesting. The incident energy available, I think people just severely underestimate. A stick of dynamite, one stick of dynamite is approximately 2 million joules of energy that's released when that explosion occurs. So what's 2 million joules of energy? Well, a joule is a watt second, right? So a joule and a watt are essentially the same thing. So that's a 2 megawatt transformer. Mm-hmm. So you literally have the energy present on the output side of a 2 megawatt transformer equivalent to one stick of dynamite. That just kind of puts it into perspective for you, what you're really talking about in terms of the energy that's present there. So if you get in a situation where an arc flash occurs, and you've got a transformer that size, you not only have a tremendous amount of heat, you got burned. You're talking about temperatures that are, compared to the surface of the sun, it's white hot. It's like an arc weld. But you've also got that amount of energy superheating the air. And as you superheat the air, you create a compression wave. That compression wave has a tremendous amount of force. I mean, it can blow the doors right off of equipment. And that's most arc flash deaths are caused by the compression wave. You don't get electrocuted, you get burned, but that's not actually what killed you. It's the compression wave that typically kills you. So, and that's the thing, if you got a little mining operation in your basement and you're running off of the 240 volt service, that powers your house, the arc flash potential there, the incident energy available isn't that great. We've probably all had something in our house, go on us, and it pops, and it's a little bit scary. Maybe it blue flashes your eyes or something, but it's not going to kill you typically. But when you're talking about a 2 megawatt transformer, you're talking about a stick of dynamite. And the thing that scares me the most with these containers is you get back in them, they typically don't have two means of egress, and that occurs in a container like that, you're trapped. And that's the scariest thing that I see with the containers is, you're surrounded by this energy, and it's a significant amount. The explosive potential is not small.
Eduardo, when it comes to transformers, what are some components that we see people maybe overlook that are helpful or safer?
Yeah, I'll mostly focus on the practical steps you can take to both reduce your downtime as you're looking to maintain that transformer and just avoiding some unsafe opening of the cabinets or something like that. You do have gauges on transformers. Sometimes those gauges have contacts, but even if they do not, it's still worth asking them to be placed on the outside of the transformer and not within the cabinet, so that you don't have anyone who wants to see the life of that transformer. Sometimes, again, miners aren't so worried about standard operational procedures on maintenance, and sometimes not quite hiring the right kind of guys to come and take a look at their equipment. So bringing those gauges to the outside of the cabinet can be very helpful. The drain and sample valve, you do want to take your DGA analysis of that transformer probably yearly, and instead of just de-energizing that transformer, opening the cabinet, you can just do that if you place it on the outside. So there are some simple steps you can take to reduce your potential for danger, and also as a plus, you don't need to turn that thing down and off.
Could you explain DGA testing, what that is? I think that'd be helpful for people to understand.
Yeah, transformers, you can tell so much of their life and whether they're overheating or not, or if there are any dissolved gases. That's dissolved gas analysis is really what DGA stands for. Just by taking that oil sample and sending it to a company, usually it's not more expensive than $20-50, and you get basically a full diagnostic on the dielectric liquid insulating that transformer, and if there is some sort of overheating, or if there is some sort of if there was a fault or some blown fuse or something like that, you'll be able to get a picture of just how bad the oil inside of it is. And it can be important to swap that oil out if necessary.
Yeah, it's a blood test for a transformer. It's a predictive blood test. Helps you preventative maintenance and all that stuff. Keep up on it. What are some code violations that people need to be aware of when they're dealing with creating their mining operations?
So I don't think we have enough time to hit all of them, right?
What's some of the major ones?
Right. So a lot of people try to skip on wire size. Wire size is a big one, and fill rate when people use conduit instead of cable tray. So if you've got X number of conductors you're trying to shove into a 2-inch conduit, there's a max. Like you just can't pull till it's full.
It's hard to pull
right?
it out. Yeah,
exactly. Because what that does create excess heat, insulation failure, ground fault. That's a big one. The other one that we see are proper grounding, like we've hit on several times. Every time you've got a transformer, it's got to go to building steel. On your main service rate entrance, you've got to go to the water main. And these are things, again, like we went to in the beginning. Use a professional. Like if I could give anybody the best advice that's possible, talk to somebody who's a professional, not whoever. Joey Bag of Donuts is like, oh yeah, I've done this forever. Well, are you certified? What's your degree?
Watch
how much
YouTube.
experience?
You watch a YouTube video.
Right, exactly. And there's unfortunately there's a lot of that in our industry, right? There's folks say, oh yeah, I've done a million of these. Let me see them. Like, do your due diligence. Hire people who really know what they're doing, because you're actually putting your life in these folks' hands, and you have to be selective. Don't take a shortcut.
Yeah. How about you, Ken? Code violations, things they need to think about?
One of the wire sizing, fill rate, seen both of those. The one that caught me off guard here at the show, not going to call anybody out, but there's an 80 amp circuit breaker with 4 number 10 wires connected to that circuit breaker. And it's not even close to a gray area, right? It's just a straight up severe code violation. You just can't do that. There's an electrical code is one thing, building code's another thing. I'm seeing a lot of clearance issues where, and I think there's a confusion because the miners are 240 volt devices, right? but they're all fed from a 415 volt feed. So the panels that are feeding these things have to be treated like 400 volt class panels in terms of electrical clearance. And the electrical clearance for a 400 volt class panel, from the panel to a grounded wall, is 42 inches. And all over the conference yesterday, I'm hearing, 32 inches, 36 inches. 36 would be appropriate for a 240 volt. But this is a 400 volt class system, 42 inches. And if you're putting them face to face, if you've got them in that configuration, then you're 48 inches. And I'm not seeing 48 inches of clearance in most of these containers. So, and then, also egress is another thing. Because really, I think, and I'm not a building code expert, but technically, I think these would be defined as an electrical room. And electrical rooms have a whole nother set of codes beyond the building code. Additional egress. You have to actually have room so if the door to a cabinet is open, you can still egress past that cabinet. Things like that. So I think serious evaluation of the building code as well as the electrical code needs to be thought about with this container product, because I'm seeing clearance issues that are serious violations.
That's helpful. Well, we want to tie up. I just want to thank everyone for coming this morning. Y'all that are recovering from being out probably pretty late last night. One of the advantages of being at Mind Disrupt is having all these different people in these different areas together that understand code, that understand the standards. I'd encourage you all to take advantage of that. It's great to see the industry maturing and seeing things that aren't just like thrown together with things here and there that's going to kill people, but also get your operation down. So again, thank you. Please thank our panel members right now. So, all right, thank you so much.